Hello and welcome to the Chandra Academy. In today's video, we are going to solve this exercise about the full study of a function. In this exercise, we are going to study what is called a rational function, which is the division between two polynomials. Okay, first, we are going to find the domain df of definition of the function f, then prove that f can be written in this form, and this form would be especially useful when we will want to calculate the limit in some interesting values, and then find the vertical and slant asymptote of c, which is the graph of f. Then we are going to study the variations of the function, so going through the study of f prime of x, and finally sketch the graph C. Let's start. Our function f, given f, x gives back x squared minus 2x minus 3 over 2 minus x. What is the domain of definition of this function? This function is obviously defined when we do not divide by 0. When this thing is equal to 0, there is a problem. And this is the only problem that could come from this function, because polynomials are easy functions defined on R, but here the only problem would be a division by 0. So we want f is defined for all x, such as 2 minus x is different from 0, which is equivalent to x is different from 2. And we want x different from 2, and we conclude by df, the domain of definition of x is equal to R, so all x's that are real number, without the single element 2. And we have solved the first question. The second question, we want to prove that f can be written as minus x plus minus 3. So we want to prove that f of x is equal to minus x plus minus 3 over x minus 2. Obviously, 2 minus x, 2 minus x. What can we do to prove that? Is to come from this expression of x and trying to put everything under 2 minus x and see if we have the same thing at the top as our original expression, this thing. Let's start. So this expression, so for all x different from 2, minus x plus minus 3 over 2 minus x is equal to minus x times 2 minus x minus 3 over 2 minus x. Very easy for now. And this thing is equal to minus 2x distributing this thing here, plus x squared distributing here, minus 3 over 2 minus x. And this is equal to x squared minus 2x minus 3 over 2 minus x. And this is the exact expression we have here. And so we prove that this thing is equal to this thing. So obviously, as this thing is equal to f of x, we've got f of x is equal to this expression here, minus x minus 3 over 2 minus x for all x in df. And we have solved the second question. Now that we have this second question, this is really easy to find the limits, which is the third question. So third question, the limit we want the limit, we want the limit of f of x when x tends to plus the infinity. Okay, when x tends to plus the infinity. So x tends to plus the infinity implies what? Implies minus x, obviously, that tends to minus infinity, because here we have plus the infinity times minus 1, which is equal to minus the infinity. And minus 3 over 2 minus x will tend to minus 3 over minus the infinity, which is equal to 0. Okay? And adding both, we've got minus x plus minus 3 over 2 minus x, that will tend to minus the infinity plus 0, which is equal to minus the infinity. And so we can conclude by saying that limit of f of x when x tends to plus the infinity is equal to minus the infinity. First limit. Second limit, x tends to minus the infinity, implies what? It implies that minus x will tend to plus the infinity, because we've got a minus 1 times minus the infinity, which is equal to plus the infinity, and that minus 3 over 2 minus x will tend to minus 3 over plus the infinity, and this thing is equal to 0 as well. Okay, and so adding both, we've got minus x plus minus 3 over 2 minus x, that will tend to plus the infinity when x tends to minus the infinity. Okay, so second one, let's conclude. Limit of f of x when x tends to minus the infinity is equal to plus the infinity. Perfect. Now we want the limit when x tends to 2 minus. So if 2 is here, we want the limit when x tends to 2, but coming from the left side. So never reaching 2, which is a forbidden value, but going near on the left side. This is very important. 2 minus of f of x. Okay, so when x tends to 2 minus, it implies that minus x will obviously go to minus 2, very easy, and we will have 2 minus x that will tend to 0 plus, because we are subtracting 2 minus 2 minus, which is something a little bit smaller than 2. And we've got something that is a little bit greater than 0, which is 0 plus. And this implies that minus 3 divided by 0 plus will be equal to, it implies that minus 3 over 2 minus x will tend to minus 3 over 0 plus, which is this value. And this is equal to minus the infinity. 3 divided by 0 plus is equal to plus the infinity, times minus 1 is equal to plus the infinity. And so limit of f of x when x tends to minus is equal to minus the infinity. For the value of limit of f of x when x tends to 2 plus, this is the opposite thing. We want to approach 2 coming from the right side, and so we will still have minus x that will tend to minus 2 when x tends to 2 plus. We will have 2 minus x that will this time tend to 0 minus, following the same idea with this one. We are subtracting 2 plus, so something a little bit greater than 2 to 2, and so we are left with something a little bit smaller than 0 when x tends to 2 plus, and this implies that minus 3 over 2 minus x will tend to minus 3 over 0 minus when x tends to 2 plus, and this implies, and this thing here is equal to plus the infinity, because we've got something negative here, very small and negative, that divides something negative. And so minus times minus is equal to plus, and 3 divided by 0 is equal to plus the infinity. And we have our solution, limit of f of x when x tends to 2 plus is equal to plus the infinity. And we have solved our third question. This is it for the first part of the video. In the second part of the video, we will try to find the vertical and slant asymptotes of C, and then study the variation of the function f, and finally sketch the graph of f. Hope you enjoyed the video. See you soon. Bye.